So this is the SN1 reaction mechanism in organic chemistry, and it is very similar in result to SN2, though not quite exactly the same. So it's a substitution. We'll be replacing a leaving group of some kind with a nucleophile. So from start to finish, we're going to add a new group, replace an old. So by product, it looks somewhat similar to SN2, though there's a lot of important details. Overall, the mechanism generally starts with just bond breaking. So leaving group is removed in the first step, Lg minus with a carbocation. Right, since we have a carbocation, you got to think about carbocation rearrangements in these mechanisms. And then the second step, so two separate steps, then the nucleophile adds. And so we've done a substitution in this case. Our example will be a little bit more complicated than that, but not too much. And so first step is always leaving group coming off. That gives us the carbocation, Cl minus, and water is still just hanging out. So in this case, we got to think, is this going to rearrange? But no, there's not a more favorable position there. So then the nucleophile can add. So the weaker nucleophiles that you usually see in SN1 reactions tend to be neutral, and then when they attach, it's usually important to write them out in a long Lewis structure style so we can see all of the bonds in this case, because if we need to make changes or break those bonds with our mechanism, we need the covalent bond straw in this case. So not quite done here. We have our first intermediate, our carbocation, but since we use a neutral weak nucleophile, we need an extra proton transfer to finish this. So most likely another water would be doing this step of the reaction and doing a proton transfer, removing that last hydrogen and giving us the alcohol. I'm going to draw it over here. So there's a lot of products in this case because unlike SN2, where the stereochemistry we had, then we ended up with the reverse in the product. With SN1, once this bond breaks, then the stereochemistry is wiped out. But in this step, the water can add from above, like into the board, giving us this product, or it can add from behind as well, giving us this product. So you get a mixture of stereoisomers if you have a chiral center product. Right? The leaving group is left behind, and in this case, a water molecule has picked up a proton.